Yeah, this is Through the Looking Glass and What Eve Found There by Queso and Emdal, so please join me in giving them a huge welcome.
Okay, welcome everybody. Before starting, first of all, yes, you're not in the wrong track. This talk is about backbone routers, mostly. Not directly backbone router, but how to access them by exploiting something else. And in this case, this is why the title. We are talking about looking glasses. I'll tell you what looking glasses are if you don't know them, and what we found in our research in order to exploit them. Actually, I'm not Emdal. I'm Luca Bruno, and this is my colleague Mariano Emdal Graziano. And we're going to talk you through this presentation. I'll talk about the first part, the introduction, and it will give some more details about the attacks and the exploitation part. Before starting in other details, we are both coming from Europe, so we are researchers in Eurocom in France. We are researching several topics in general in system security. I'm mostly into embedded system, networking devices in general, and critical infrastructure, while Mariano is a PhD student. His topics are mostly malware and forensic stuff, and he's currently here in the US at Cisco doing his internship. So, okay, I think that I give you already a small presentation about us, so let's get into the details. First, I know this is gonna be a bit of a bizarre talk because this is not something that you see every day. I mean, looking glasses are not so commonly used. And the reason of this research is also a bit bizarre. So let me guide you through the why we did this. Imagine for a couple of minutes that actually you are an attacker, some kind of very lame and newbie attacker. You are starting your first steps in the offensive part of security, and you're looking for your next target. You're a bit lame in the sense that you want to go big, so you're looking for something that is, let's say, it's quite a big impact, but your skills are not so high. So let's say that you're looking for something that is some kind of critical infrastructure or global infrastructure, where the impact of what you can do will affect a lot of people in different geographic areas, but you don't have a lot of skills. And you also don't have a clear goals right now. This is actually because we will not get into a lot of post-exploitation, but we have just a general idea that you want to cause a bit of damage. Okay, so let's think about this. Let's say that we want to target the internet because, okay, it's the most used infrastructure around the world. Everybody is relying on that for economical, personal, whatever activities. If you want to target something of the internet that is touching a lot of regions and countries around the world, maybe you want to target actually how the traffic is exchanged between different and several autonomous systems around the world. So we'll talk a bit about inter-autonomous system routing. I told you already that we imagine that our skills are not so high, so let's say that we are some kind of web script kid or something like that. We know the basic of cross-site scripting, general injection, we know a bit of Google hacking, and some more kind of sort of SQL injection and in general common injection. And we still don't know what we want to do once we get to our target, but in general we know that some kind of interesting target could be the backbone of an operator. So in general, we want to go with our limited skill in the web field to something that is like a backbone or BGP router in an autonomous system. So what we are going to do is not attacking directly the BGP router, the backbone routers. We are not hardcore exploiters, and we are not coming up with a 0-day for Cisco or Juniper. Instead, when we went through this mental process, we found one really good candidate, which is a looking glass. A looking glass actually is something that I will explain to you later, but fit well in this model where you just require a bit of web notion, web exploitation knowledge in order to get big. So I hope that everybody here knows more or less what is a looking glass and how to use it. If you don't know it, I will give you a really brief presentation of it. So let's go through an introduction about looking glasses. First, one step back, let's talk about the internet. Everybody's using the internet, but actually the internet is not a single network, it's not a single entity. The internet is composed, we can describe it as a network of networks. It is in fact composed by a lot of entities, commercial, non-commercial, private, financial, university, government. In the internet in general, we have a lot of operators. We call them autonomous system, AES, in the rest of this talk. And each of these autonomous systems has its own network. There are different kinds of networks. There are access network, transit network, depending on what your target and what your economical business is. And all these networks are in somehow interconnected by one protocol. This protocol is the BGP. It is what is governing how the traffic is flowing across the internet. The result is something like the diagram that you see here, where a lot of ranges, a lot of IPs are interconnecting, and there is a path that is usually connecting autonomous system A to autonomous system C, passing through autonomous system B, B1, B2, and whatever. So let's keep in mind that we have this protocol, BGP, that is governing all of the internet, and let's see how in practice this routing works. We normally talk about a BGP routing table that is something that will tell you, okay, in order to reach that IP address, that IP subnetwork, you have to go through so many autonomous systems. That's fine. But in the details, actually, there isn't a single BGP routing table. What we have really is that every autonomous system has its own policy, has its own decision-making process, and also internally to BGP there are different algorithms and different ways to calculate which is the best route in order to reach your target. So what we actually are seeing is something more complex, where every single autonomous system has a local view, a local routing table that is used, that the traffic is following in order to reach the destination. But, as we may imagine, different autonomous systems may have a different local view of what is the routing table. So could happen some interesting situation, let's say. I'm not an expert in BGP, so I'm not gonna too much into the details, but what could and usually happen is some kind of anomaly where, for example, the same prefix could be announced by different autonomous systems, by error or in order to attack and hijack prefixes. I have one example here. This is courtesy of Thousand Eyes analysis. For example, this is the incident where Indosat was announcing the PayPal prefix. As you may see, the same prefix was being announced by two different autonomous systems. The correct one of PayPal on your right, the blue one, and another one that is Indosat that was by mistake, let's say, announcing the same prefix. In that case, some autonomous systems, the ones that are marked in yellow, red, and orange, were seeing the announce and following the announce on Indosat. So whenever you were trying to connect to PayPal, in fact, you were reaching India. And in the other side, there were some autonomous systems that because of policy or proximity, they were instead following the announce, the correct announce of PayPal. So in this case, what's happened? You have some kind of asymmetric or non-uniform routing, and imagine that you are the network operator center or NOC engineer of one of these autonomous systems in the middle. One customer is calling you and is telling, hey, look, I have some problem reaching PayPal. And you have to debug it. How can you debug it? Or you are an engineer at PayPal and somebody is calling you and telling, hey, I cannot reach PayPal. How can you debug this situation if you are PayPal and you know that your announce is correct? What you can do is troubleshooting. Everybody does troubleshooting and debugging of connectivity issues. You need tools to do that because you are in a situation where your local announce is fine, but something else in the other side of the world is doing something bad, and a third-party autonomous system is having problem, and you want to debug this situation. You need tools in order to do that. In particular, you need something in order to get a view on the remote status. We can come up with several tools and several solutions. One is something like setting up a community, a distributed network of probes. So let's say that we are 4 autonomous systems. Each one we are receiving different analysis and different BGP information. We all collect this information in a central location, and there is some kind of services that is exposing all this data and keeping chronological track of it. For example, we are coming from Europe, and RIPE has this kind of services in the RIPE labs, where basically you can crawl and look at the history of BGP analysis from multiple points, usually at public internet exchanges. Another solution that you can come up is some kind of private agreement. For example, there exists some rings, like the NL-NOG ring, where you are an autonomous system, you participate in this ring, and once you are part of this ring, you will provide one system, usually a Linux server, inside your autonomous system, and giving access to this system to other network engineers in other autonomous systems. In exchange, you will get the same access somewhere else, so that every time that you have a problem, you can log in a remote system, in multiple remote systems actually, run distributed command, for example, ping or traceroute, and compare them in order to see what's going on and where the traffic is being lost or whatever. The third idea that you can come up, actually something more general. So let's give the whole public, not only network engineers and not through a central point of failure. Let's give the large public access through the web to our routers. As you may imagine, this is something that sounds a bit scary, in the sense that you need some kind of web services that is directly exposing some limited feature of your routers in order to do debugging and get information on BGP. So actually we're going to focus on this. This third tool is called a looking glass, and we're going to focus on this kind of software and see how does it work, what are the vulnerabilities that we found. We also found some incident, and let's go through it because it's scary stuff. So what's in a looking glass, first of all? Looking glass became famous, common, let's say, in the 90s and in the first years of 2000s. Usually, looking glasses are very simple software. They are web script in the sense that they usually compose of one file, couple of files, a bunch of files, nothing very complex, not a big architecture. This is something that you just download, unpack, and put in your web server root and forget about it. They are usually written in Perl. A lot of them are written in Perl because it was the 90s. And some of them are written in PHP because, hey, everybody loves PHP here. How do they actually work? They establish a direct connection from the host that is hosting a looking glass to the router administration console via SSH, Telnet, or whatever methods you have to administer your routers. And obviously, you need some kind of credential in order to log into a router. So how does it work? You have a clear text config file with credential and whatever on the same host, and the web script will use this information in order to connect to SSH. As you may imagine, this is something that is becoming scarier and scarier as we go on, because if something goes wrong in all this stuff, okay, you have a big goal. How does it work in practice? Let's say that we are an operator, the autonomous system on your left, and we want to provide this kind of looking glass access to the rest of the world. What we're going to do, okay, we already have our routers, the 3 routers on the left, which are handling our internal network and the external connectivity and everything else. We then add another system, traditionally a Linux system, that is the bottom one on the left. This system actually has 2 legs or links. One link is going on the right to the internet, to the public internet. This is where you expose your web access. This is actually where the other operator, the other engineers that are, for example, the 2 on the right, are going to connect and use your web interface, your web service. On the other side, the same host has another leg, which is going to the left, connecting connecting this service to the private part of an operator network. I call the private network of the autonomous system, where you usually have all the console and administration services that you don't want to expose to the whole world, because they are a bit critical and you don't need to do administration of them through the internet. So actually this is something, let's say that the Looking Glass is a bit critical because it sits at the border between the public part of your network, which is something fine, okay, that everybody can reach, and the private part where actually you have critical services. How does it look like? I hope you love the 90s, because this is like a clear, simple 90s interface. You just have the minimal that you need in order to select which kind of command to run. For example, you have connectivity issues, you want to run ping and trace route from this autonomous system to your own IPs, or you want to see how the announces are going, so you can see some kind of advanced or reduced summary of the BGP announces. Then you usually have one form when you can input some other additional parameters, like which host, which IP address do you want to ping or trace route to. And what I was showing before in the slides is that one Looking Glass can be connected to multiple routers, actually to all the routers that are in a single autonomous system, so you can select on which router actually you want to run. Imagine that you are a geographically distributed autonomous system, so you're covering multiple regions and multiple exchange points. You have routers at all the exchange points. They may have some different topology configuration, so you want to run commands on specific routers in specific geographical location. What we did in this research, it's, okay, let's focus on what we can actually review and check. There are a lot of custom Looking Glasses, so imagine that you are an autonomous system. A Looking Glass is quite simple. It's just a web service that is connecting to SSH and Telnet, so you can write your own. This is a bit difficult for us to review because we don't have the code, and we cannot set it up in our own lab. So in order to try to assess and exploit it, we actually have to attack an autonomous system, and this is clearly not feasible, not legal. What we did instead is take a list. There are several lists actually of public Looking Glass around the world, crawl through them in order to see if anybody, or if a large majority of them are using open source software that we can download and examine. And actually the answer is yes. There are several, in particular there are these 4 that are mentioned here, that are quite common, probably because they were the first to be written, and it was a period where they were highly needed and a lot of operators were just downloading them and deploying them. As I told you already, a lot of them are written in Perl, and then there is one that we all love again, it's written in PHP. What we did in the rest of the research, and Mariano will show you later, is reviewing the code of these Looking Glasses and also looking for all the vulnerabilities. We found several vulnerabilities, and then looking at how widespread their deployment was and which kind of incidents we found in the wild. Before proceeding further, just to frame a bit how we're going to proceed, Mariano will show you several vulnerabilities and incidents. We started from the basic, like assume that this software is bug-proof. Still, there could be error in how you deploy it. The human, the administration can make errors. Let's say that you have to deploy a web script as CGI, but you forget to enable the CGI, or you forget to protect your configuration and SSH key. In this case, we may see some exposed credentials. These are router's credentials. Then, go one step further. Let's say that we try to find bugs in the web application. Here we have basic web skills, so we look for the normal, the usual culprits, like improper escaping of inputs. Let's imagine that we can find some kind of cross-site scripting there. It could happen. In this case, we can use it for normal stuff like cookie stealing or attacking other web services in the same site. One step further, some of these Looking Glasses may come with additional modules. For example, they may come with binaries, native stuff, or forked modules. If we find bug in these modules, actually we can attack directly the host, not the software itself, but the host. The host is the one that is actually storing the credentials. So once we have access to it, we already have a stepstone into the private side of an operator network, and we can also steal the credential. Then stuff gets really scary because, okay, let's focus on the backend of the Looking Glass. The Looking Glass is connecting SSH telnet connecting to a router while allowing just a limited set of commands. Okay, but let's see if it is really a limited set of commands or if we can inject whatever command we want directly to the CLI of a router. If we can manage to do that, we are escalating from a basic web attack to something where we actually are attacking a critical infrastructure backbone. And as a side case of this, let's say that, okay, we can do that. We can log in and control multiple routers. We can attack multiple autonomous systems. We can actually chain different vulnerabilities. So the one that we found is some that are already known, that are in the backup slide. I don't know if we have time later, to actually attack the network. Once we are in a router, we can try to escalate and change the modification of this router in order to break havoc of the local traffic, so rerouting, changing the local topology, or in theory, also announce bogus prefixes in BGP in order to have a worldwide impact. Some of you now may think, this is for sure not possible because we have best practices. We all know that BGP announces are filtered at the border and whatever. In theory, yes, that's correct, but what we are going to show you through the rest of this presentation that best practice exists, they are well written, but often they are disregarded. We also have another paper at Wood that is describing more the details on that, and we actually believe that this kind of attack is feasible with what we have found, but for clear legal motivation, we cannot perform that. So, sorry for boring you with this big introduction. Let's get into the meat of it. Mariano will go through the vulnerabilities and the incident, and that's the scary part.
Okay. Hello, everybody. I'm Mariano. Okay, hello everybody, I'm Mariano. Today I will talk about our findings that are, as Luca told you, are more on the offensive side. Okay, are more on the offensive side. And in particular, during our research, we have found several vulnerabilities and incidents affecting the most common deployed open source looking glasses. So let's start. Okay, if we remind the definition of a looking glass is something related to the web. So it's normal that the first kind of problems come from the web. When we'll talk about web issues, basically we have two kinds of problems. The first one, it's related to web misconfiguration, and the second one is more related about common web vulnerabilities. Now I will give you two quick examples one about the web misconfiguration and one about common web vulnerabilities. For example, one, in bad configured looking glass, it's possible to retrieve the router credentials. This means the IP address, the username, and the password. Then this is possible actually because the configuration file is stored at a known address with the wrong permission. Then, for example, for the common web attack, we found a couple of cross-site scriptings. That I know this sounds like a joke. I mean, what I can do with a cross-site scripting in a looking glass. But actually, sometimes, for example, ISP providers and network operators set up under the same origin other admin web application. Now, let's talk more in details about web misconfiguration. During our research, we were able to find a couple of configuration files with a simple Google Docs. They are really simple Google Docs, guys. It's not the real advanced Google hacking. Here in the slides, you can see two very basic examples. They are really easy to craft once that you know the configuration file structure and syntax. Now, let's have a look at the real Google Doc here. As you can see here in the output, you have, in the Google output, you already have the terminal credentials. This means the IP address belonging to, of course, to a backbone router belonging to a weak autonomous system. Then you have the username, and then you have the password. Now, of course, here the output is already in the Google query because the looking glass is bad configured and has been indexed by Google. Now let's have a look more in detail about the configuration directory of this Google result. As you can see on the left side, on the right side, sorry, you have the configuration directory. Basically, is we can list it because it's bad configured and is readable. We have several files, like for example, the configuration file, and then another interesting file is the log file for the looking glass. On the left side, we have the real configuration file of this autonomous system. In this case, we have a case for the Cougar looking glass. This is one of the most common deployed. It's important to notice here the structure. We have one entry for every router exposed in the web interface. Every router entry needs a router name, and then, of course, the credentials that is composed by the connection method that can be Telnet, SSH, or RSH, then the username, and then the password to log in. Then, another problem related to web misconfiguration is related to the default configuration path. For example, if we download one of the most common deployed looking glass, and we have a look at this root directory, we have several files. Here it's really easy to spot the configuration file that is in blue, the lg.conf, and once that we know the name, basically we can just scroll the web. It's really easy to have a list of all the available looking glasses, and basically you can create easily your own crawler that check for the base address of the base looking glass address, and then the name of the configuration files. And if you're lucky, you will find several cases of bad configured one because they are readable and you can download them. Of course, there are best practice, okay? So if you have a look and read the README files of all these looking glasses software, the author of the looking glass warns the network operators about the security implication of the configuration files. For example, as we can read here, it's written clearly that make sure that there is no word read access on the configuration file since it contains your Cisco passwords. Hope you get it. I mean, we proved that some guys didn't get it, and in the wild we have found about 35 exposed cases in which you easily you are able to retrieve the configuration files, and this means the backbone router credentials. Then let's have a look at other funny findings on our research. Here we have two well-known websites. One is the CERN, one is the GAR. They are running some looking glasses. Everybody here in the audience knows the CERN, that is Switzerland. The GAR is also quite famous in Italy. It's basically the network of research institutions and universities. Here for the CERN, we are able to retrieve the source code of this looking glass. It is basically a common Perl one. While for the GAR, notice that this is not the real looking glass running in the GAR. It's probably an old one and is not currently deployed, but still, we can have access at this custom PHP code. And if you have a look at the code, you can find several security issues and give you the idea about the problems that a looking glass can have. Okay, let's continue. Another problem always related to the web misconfiguration is related to the exposed private SSH keys. For example, if you have a look at the configuration file or one of the common looking glasses software, at the given line, of course, if the connection method is, for example, SSH, you can have the configuration path of the private key. Again, if you create your own crawler, once that you know, of course, the path of the private key, and you start crawling the web for the looking glasses website, you can find several cases. For example, one of these cases is here in the slides. On the top part of the slides, you can actually have the private key of this SSH daemon on the router backbone. And then if we, for example, try to read the .ssh directory, again, we have another problem, a configuration problem. We can list the directory and it's readable. We have several files, like, of course, the private key. We have then the client SSH configuration files. and also the public key, because, we never know, so. Then, let's have a look now. Let's focus more our attention on the web. If I remind you now the definition of a looking glass is this web application that is directly connected to the backbone router. And we understand that the main attack vector, of course, comes from the web. During our research, basically we have found that there is a total lack of prevention of possible abuses. In particular, for example, there are no captcha at all on these softwares. This means that an attacker can easily automate several tasks, such as, for example, the resource mapping, can automate the command injection, can even, for example, attack from several devices a victim from a different autonomous system. And I know that it sounds really lame, but for example, you can create your own, let's say, fake DOS botnet from using all these devices because you don't have any captcha, and you can send commands and, for example, DOS a victim. Now, let's have a look at the first kind of vulnerability that we have found. It is a simple cross-site scripting. Here, the problem is in the HTML tag title, and is via the addr parameter. The addr parameter is basically the parameter directly taken from the web form. I know that, some people can complain here about, again, the impact of a cross-site scripting. But again, some network operation services can run under the same origin domain. And for example, you can steal cookies and execute your own JavaScript code for whatever purpose you have. Here there is an example. Okay, as you can see here, we have the looking glass interface. In the command, basically here we can see the addr parameter that we have, of course. For example, we are trying to trace. What's going on? Okay, keep going. Okay.
They're waiting for you.
Okay, I continue. Sorry. Okay, so here we have the parameter. As you can see, the problem is with the title, and then you can inject your JavaScript code, and then it's executed, and you can do whatever you want, basically. Now, this is the big part of our talk. Basically, here we have a router command injection. If we remind the looking glass definition, the problem, we can easily understand that the attacker dream is...
Now stop.
Now I have to stop.
That's bullshit. Does anybody know what's going on?
Cheers.
What?
Raise your hand if you're a first-time speaker.
Raise your hands. All right, love for the new speakers.
APT.
Cheers. Not bad.
Good luck.
Okay, thank you. We can continue after this shot. Okay, so we were saying, okay, the attacker dream is basically to execute code directly from the web interface on the backbone router console. Unfortunately, this is the case on one common deployed looking glass software written in PHP. Here the problem is again with the argument parameter. The argument is the parameter directly taken from the web form. Here the author of this looking glass has a kind of confusion between the HTML escape meaning and the real input sanitization. But here we have DEFCON, so let's have a look at the code. I hope that it is readable. Otherwise, anyway, you have this argument parameter taken from the web form that go directly a PHP function. I hope that you are familiar with the PHP that is called trim, that remove basically all the spaces from this input variable. Then this parameter passes through the safe output function that is a simple wrapper around HTML entities PHP function. HTML entities basically try to translate all the possible chars in HTML entities. And then basically the argument is directly sent to the backbone router. So it's a simple, straight HTML escape without any input sanitization, and your command from the web go directly on the backbone router. Here you have the cool proof of concept. As you can see here, you just have to keep in mind that, for example, to concatenate commands, for example, here you use the new lines, but it's important to notice that, okay, the concatenation depends on the router vendor and on the router software, so you can use, for example, pipe or whatever you want. It depends on the router. Here the command that we perform are, for example, date and exit on our lab environment. Okay, now another kind of problem that we have found on our research is a remote memory corruption bug. This time the problem is that sometimes the Looking Glass has some other third-party software embedded in their installation package. For example, one of the most common deployed Looking Glass has this utility that is called FastPing that is based on the real ping and has been written by 2 Italian students. Is a fast that we are not me and Luca, but there are two other students, of course. And this FastPing utility is a SUID binary. Here the problem is that the ICMP echo reply is not properly sanitized, and we have a kind of memory corruption bug. Again, let's try to have a look at the code. Okay, first introduction. I'm sorry, but the code is written in Italian, and the comments are in Italian. So I hope that you are familiar with the Italian. But anyway, the idea here is that you have this function that is called riempie ritardi, but means that fill the delay tables. This function has 2 parameters, an index and a delay. Okay? And then we have a general of a global array that is called delays, okay? That has a fixed length. Then this function basically writes directly to this global array using an index that comes from a field of the ICMP echo reply. Of course, if an attacker provides an index that is above the fixed length, we have a memory corruption. Now, the exploitation nodes, here the problem is that, okay, we have a third-party binary that sometimes, okay, is in the default installation package, but of course, then the network administrator can decide to not deploy it. And the FastPing utility is no longer maintained, and these are the 2 reasons why the current author of the Looking Glass software won't fix this issue. Now let's talk about the real exploitation part. Okay, we have to keep in mind that we are dealing with delays, so the exploitation is time dependent. The problem here is that, okay, we can basically have a kind of workaround about this time problem because from the ICMP echo request, we have a field and we can retrieve the host side time. But then the other problem is that every time that we run these FastPing utilities, we are sending 100 basically ICMP echo request packets. So the attacker then can send up to 100 ICMP echo reply. So basically we can write one long parameter, 100 long parameter in memory on the target. The point is that, okay, it's not trivial then to subvert the control flow of this application. I still have a bet with Luca. We are at DEF CON, so this is a challenge for you guys. We are not providing any code. Now, I talk more about web misconfiguration and other kind of issues, more related to the web vulnerabilities. But we have also other kind of problems, like, for example, bad configuration network designs. This is because, for example, the network operators basically make the router interfaces public. We can retrieve easily from the Looking Glass the IP address of these exposed routers. We can, for example, try with Nmap to have a look at what services are running on these routers. And here we can see that we have exposed the SSH and the Telnet daemon. Oh, sorry. Okay, now Luca will talk more about some fixes and possible mitigation of all these problems. Go, Luca.
Okay, so that was actually the cool offensive part. We found out to inject command basically several vulnerabilities and incidents in the wild. And in general, we found a lot of disregarded best practices. There are a lot of countermeasures for these kind of issues. So I think that we can split countermeasure in 3 fields, basically. The first one is looking at the code. This is open source stuff. In general, it's Perl, PHP, web code. We have to do a lot about the code. Then we have to improve our deployment methods. And if you are a network designer, a network architect, or a network engineer, please apply some best practices. First, let's start, everybody, understanding and acknowledging that if we have a service, a web service that is exposing some kind of connection to a router, so to some critical services, to the web with hard-coded credential, okay, this is like a dangerous case. This is some kind of security high-impact target, and we must know it and have a proper look at it. In particular, looking glasses are just one example. There are a lot of services like that, which has been written in the 90s usually, and has been forgotten since then. Okay, it's 2014, 2015. Let's have a look from the security point of view to the code and review it. From the deployment side, we can do some steps in order to improve this situation. For example, there are a lot of cases where you don't need to connect this kind of services directly to your critical infrastructure. We found a lot of looking glasses that are connected directly to backbone routers and operational routers. You can set up looking glasses in other ways. For example, provide just one system that is mirroring all the BGP routes that you know, and it is providing just some tools like ping and trace routes, some kind of sandbox or playing environment that even if an attacker can get into it, is not a big problem. Then, once you have deployed this kind of service, actually check that everything is fine, that one public attacker cannot reach it over the web or your configuration clear text SSH key. And even if you did all your configuration perfectly fine, check for other stuff that is on the same host. For example, we found some cases where the virtual host for the looking glass was okay, was perfectly configured, but then if you were accessing the same host through the IP, so through the normal default doc route, you were able to get to the same files. And the last point, if you are a network engineer, set up proper ACLI on your routers. A looking glass doesn't need to have a root connection to your routers, an admin connection to your routers. We found root password in configuration file. A looking glass user just need to run a couple of commands like ping trace route and show BGP. So set up a proper ACL just to do that. Then router consoles are not being tough as a possible public access point. So there are some bugs. We know there are a lot of bugs. Password hashes sometimes are very weak. It's easy to crack them. So use strong password. Don't reuse password for them. And I don't want to see any more SSH and Telnet services exposed through the web. Mariano showed you some Nmap screenshot where basically from our home connection we were able to connect to a router SSH console. Nobody in the world need to do this kind of backbone router administration from home. Autonomous systems have their own private network, they have their own private VLAN and subnet, so let's use them and put administration interfaces there. The talk is basically over. In order to recapitulate and conclude everything, what I want you to take away from this talk is that, okay, there are a lot of best practices around. We all know this, but best practices are often disregarded. We found a lot of cases where everything was basically exposed, and this kind of critical software were not reviewed, sometimes were forgotten, and there were clear bugs. We didn't show any advanced really bugs. So beware, they are sitting everywhere in critical places. Let's review, let's check them. And something that we want to highlight is also, this talk was probably a bit lame. We didn't show anything really advanced, but an attacker doesn't need something really advanced. Attackers go for the weak link. Looking glass is a really weak link. It's something that is very simple, mostly forgotten, and sit in critical places. So once an attacker gets there, it's easy to escalate. We show that you can get from the web to a BGP attack. And something that actually I found really funny, really interesting as part of this research is that I really understood that the internet core is fragile. There are so many pieces and so many critical and security flows around that I'm still amazed that the internet is really running up to date. And so that was all, basically. We are available for questions later outside of this room. I just want to thank a couple of other guys from Eurocom, basically, that has helped us and discussed a bit of the BGP problematics, and some very cool students at Eurocom that helped us in this bug finding and overall in this whole research. So thanks you guys from the NOPS team, and that's it. Thank you. Okay, there are a couple of backup slides if you want to see them. We found actually that post-exploitation is not that difficult because known bugs exist in a router console. For example, Cisco, there are weak hashes all around. There are type 0 that's basically password not hashed. Type 5 that has basically just MD5 of password. And type 4 where there is actual critical bugs. There were actually critical bugs in how hashing were done. And then once you have access to a router CLI, you can escalate quickly. Both on Cisco and on Juniper, there are existing bugs, known bugs, that you can use to get from a normal user to a root user.